Okay, a 70 kilogram man is standing on a weighing scale in an elevator. It takes the elevator 4 seconds to move up one floor, distance of 5. What do the scales say the man's mass is? Okay, so first let's get the acceleration of the man. UVATS, he's heading upwards, starting at rest. It takes the elevator 4 seconds to move a distance of 5 meters. So we'll have S equals UT plus a half A T squared. So that means 5 equals 8A, so A is 5 over 8 meters per second squared, so that's its acceleration upwards. Now, let's draw the diagram of the forces for the man. So he is standing on the scales, so through his point of view there are two forces acting on him. His downward weight, which is 70g, and the scales pushing up against him, causing him to elevate. So that is the reaction force here. Newton says F equals ma, so that means R minus 70g should equal 70 times 5/8. So R equals 70 times 5/8 plus 70g, which equals, let's see, 70 times the previous answer, that's 4, that's not right, what did I type in? 70 times 5 over 8, 43.75 plus 686.7. Now, what do the weighing scales say his mass is? Well, actually, weighing scales, there's two problems with weighing scales. The name is actually totally misleading. Firstly, weighing scales don't actually get the weight. Weighing scales, they don't get the weight. They tell you what the mass is, but they work out what the mass is from the weight. But in fact, that's not even true. It doesn't tell you what the weight is. A weighing scale tells you what the reaction force is. So when you stand on a weighing scale and it's not moving, there's a reaction force up and there's a weight down. If nothing is moving, then the R will equal the W. The R is what the scales actually reads. And the scales, when people designed it, they know that, well, as long as the scales isn't moving up or down, then the R will equal to W, and W is equal to mg. So that means the mass, what you see on the scales, will be R over G. So the weighing scales can read this, can divide it by 9.81, and then it can display what your mass is on the screen. However, if the R is bigger than the W, then it will think the mass is bigger. This is what the weighing scales this is what the weighing scales would need the reaction force to be to give the right answer. But this here is only because the weighing scales is accelerating up, because if you think about it, this was just because there was an A here. Really, the weighing scale shouldn't be moving and the A should be 0. That would make this 0, which would make R equal to 70g. So let's work out what this is compared to this as a percentage. So 43.75 divided by that. So that's about 6%. So this is an extra 6.37%. So this means the weighing scales will think he's 6.37% heavier than he really is. So instead of saying 70 kg, it will say just increase the 70 by 6%, and that comes in at 74.46. .46 kg. A tricky question.